Hi, in this video, we're going to be working in section 8.4. This is part 2, wrapping up this section, okay? So we discussed what the T distribution is, and now we're just going to we're going to have an example of how to use it. So I want to go over first to the formula card, so please open your formula card. And over here are the chapter 8 formulas. You notice that the last couple of formulas here, in particular, I want you to bring your attention to the very last formula, because these are about the T distribution. And this last one here is your formula for the T distribution. And you'll note it looks just like the formula for the Z interval, for the T interval and the Z interval. So the T interval has the same form as the Z, except we're looking two changes. Rather than going to the Z table, we're going to go to the T table. And rather than using sigma, we're going to use S. Okay, so this is the formula here. And so we're going to look at this example that's in the notes, a sociologist, and we're going to use, so it's again, the process for the confidence interval before we jump into the example. We have to have our assumptions met. So just to be clear, that even though we're not doing a normal interval, we still need normality of X bar for the T distribution to be a valid procedure. Okay, and we can get the distribution, the distribution of X bar is normal if either the parent population is normal or the sample size is large, okay? And we're in the situation now where sigma is not known, so we're gonna use S as its, to substitute some of the information in that, okay? So those are the assumptions. We still need large sample size or parent population normal. That's really the thing we kind of have to think about. So we'll find the T value, which we just practiced with, and then we're going to substitute into these formulas and always interpret the interval. So let's go through this example that I have in the notes, and then we'll do one in class together, all right? So confidence interval example. A sociologist develops a test to measure attitudes about public transportation. All right, 30 randomly selected subjects are given the test, and their mean score is 76.2, and their standard deviation is 21.4. Construct a 95% confidence interval for the mean score of all such subjects. Okay, so I want to just look at the statement of the problem, because now what becomes important is being able to read a confidence interval problem and determine if you need to use the Z test or the T test. Okay, so if you look back at the statement of this problem, I do have a standard deviation being given right there, right? So why can't I use the Z? Well, we have to look really closely at this, at the wording in the problem. What kind of standard deviation is this? Is this a sigma, a population standard deviation, or is it a sample standard deviation? Is it S? So we have to look at the sentence that sort of gives us the information, and it says their mean score is 76.2, and their standard deviation is 21.4. Who is the there that we're talking about? It refers back to the 30 randomly selected subjects. Okay, so this is a very important point, because on your final exam, there's going to be about 3 times you're going to have to figure out whether to use a Z or a T. And so it ends up being a good chunk of a letter grade on the final. So please let me get your attention and rewind if you didn't hear what I said, or I'll just say it again over and over again, because it's that important. But you have to look at the standard deviation word and figure out if it is a population standard deviation or a sample standard deviation. In this problem, their standard deviation refers back to the 30 subjects in the sample. So that's why this is an S and not a sigma. I want to take a moment and go back to a previous problem in a couple of sections earlier and just check to make sure we could compare the way the problems are stated. Okay, so just going up to okay, here's an example. All right, of samples of size 49 is taken from a class. The sample average height is 64 inches. The population standard deviation for height is known to be 1.6. So that's the sentence that has the word population, that has the word standard deviation. And let me highlight it here. Notice what kind of adjective goes to the standard deviation. It is the population standard deviation. This is a sigma. It's a sigma, you use the Z, not the T. Okay, so that's a real important point. I'm sure we'll get lots of chance to practice with it. And I hope we get that kind of organized. So we are back to this problem. So this problem, the sociologist had 30 randomly selected subjects, and this is the sample size is 30. The sample mean is 76.2, and the sample standard deviation is 21.4. We are asked to find the 95% confidence interval. So looking over here, we have again a little box that we sweep. Just because it's a T, it's the same idea. The confidence level completely determines your T sub alpha over 2. So we start over here. Confidence level equals 0.95, alpha 0.05, alpha over 2, 0.025. But what's important here is to remember your degrees of freedom, because you have to go to the correct row in the table. And so we're going to go to the degrees of freedom is, n minus 1. I didn't even mention that before, but the degrees of freedom is sample size minus 1. So in this case, the sample size was 30. The degrees of freedom are 29. So going to the 20 degrees of freedom 29 over to T sub 0.025, and go ahead and put your finger on that and see that you can find T sub alpha over 2 is equal to 2.045. So looking at the confidence interval, we have it here in that same minus and plus. I always write it out like that, you know, makes it easier to see what's going on with the calculation. And we have substituting in 76.2, that's x bar minus T sub alpha over 2, 2.045 times the ratio 21.4 over the square root of 30. Okay, same thing on the other side with the plus. That piece here, hanging off, the minus and the plus is the margin of error. So calculate that, make sure that you're confident with your calculator skills, and you can confirm that that's 7.99. So it's 76.2 minus 7.99 to 76.2 plus 7.99. And we get, this is our confidence interval here, 68.2 to 84.2. And we interpret the interval. We are 95% certain that the population mean of test scores is between 68.2 and 84.2. Or the longer interpretation, that it was if we repeated this experiment, many samples of size 30 that we would expect, and each time use this procedure for calculating the confidence interval, then we would expect that about 95% of the intervals contained the true population mean. All right. So that is it for this section. We're gonna, we'll work some more problems in class. I'll see you there. Bye.